Hello guys, in this video I would like to discuss specifically on stoichiometry and mole concept. But before, I would like to review on the fundamental definition of what is called by the atomic mass, AR, and the molecular mass, or MR. So atomic mass, if you see from the periodic table, we have actually two numbers. So the smaller number is actually the atomic number, right? So this is the atomic number, showing the number of proton and electron in an atom. And then the bigger number is actually the mass number, so representing the mass of an atom in a certain unit. So for example, like this carbon, means that the mass is 12 atomic mass unit. So this is the mass number. Discussion of atomic mass units actually made in previous videos, but at the moment you just need to know that the mass of carbon is just 12 units. So if it is just one atom, we call it atomic mass. But if it is more than one atom or creating a molecule, for example like this carbon dioxide or CO2, then the molecular mass will have to be a combination of all the atoms and the number of atoms inside that molecule. So we know that CO2 is like this. So it means that it has one carbon atom and two oxygen atoms. So the total molecular mass of CO2 is 12. This number. And 2 times 16. So why 2? Because there are two oxygen atoms here. So 12 plus 32 means 44 unit is the molecular mass of carbon dioxide, as opposed to atomic mass of carbon, which is just 12. So if you're able to understand the difference between atomic mass and molecular mass, is the gateway of the mole concept. So now let's discuss this short recipe. So it has like one piece of tomato plus two pieces of cheese would create one piece of pizza. With this information, from this recipe, if you have a certain number of pieces of any of those, you would be able to predict the number of the other thing. For example, now you have like 3 pieces of tomato. So what would be the maximum number of cheese and pizza that you can make? Well, because if you have one piece of tomato, you can, with 2 pieces of cheese, you can make 1 piece of pizza. If you have 3 pieces of tomato, you can combine these 3 pieces with 6 pieces of cheese to create 3 pieces of pizza. You can pause the video here to think of this logic in a bit. So pause this video if you're kind of confused and think by yourself, how come would we achieve this conclusion? The ratio from the formula is 1 piece needs 2 pieces, creating 1 piece of pizza. So if you have 3 pieces here, tomato, it means that you need 2 times the amount of cheese, creating 3 pieces of pizza exactly. So now you see that if we find an information about one thing, we can find the information of the other thing. So in a chemical reaction, let's say that we have this chemical reaction, 1 nitrogen plus 3 hydrogen equals or producing 2 ammonia. So what does this number actually represent? So this number is actually mole. So it means 1 mole of nitrogen would react with 3 moles of H2, creating 2 moles of NH3 of ammonia. So if we are able to find the mole of one thing, we're able to find the mole of the other things. For example, now we're trying to find the information for this nitrogen. We're trying to find the mole. What is the mole exactly? A mole is a unit of the amount of substance. So it's like 1 kilogram or like 1 liter. But mole is like the amount of a substance, the amount of particles, 1 mole, so 1 unit. So in order to find the mole, we can use this triangle, that mole is equal to mass divided by the molecular mass. So mole equal to the mass divided by molecular mass, and the mass should be in gram. So let's say now that we have the mass of nitrogen is 2.8 gram, let's say. So if you have the mass, you can find the mole. So the mole of nitrogen would be the mass of nitrogen divided by the molecular mass of nitrogen. So the mass of nitrogen is actually 2.8 gram. And the molecular mass of nitrogen is N2. So we have to take into account that it is 2 nitrogen atoms, not only 1 nitrogen. So 14. So 2 times 14. So 2.8 gram divided by 28 means that this is 0.1 mole. So the mole of nitrogen here is 0.1 mole. From this information, 2.8 gram. So now, because the number, the ratios, they're always trying to maintain the ratio. So we see that the formula is 1 mole nitrogen, 3 mole hydrogen becomes 2 mole ammonia. Then if we have 0.1, then this should be 3 times, right? 3 times of it, and this should be 2 times of it. Or if this is too confusing, you can actually imagine like this. So one piece of clothing, the price is $0.1. So if we have like 3 pieces of clothing, I would say the price would be $0.3. Make sense? Because one piece of clothing is $0.1. So 3 pieces of clothing would be 0.3. So 2 pieces of clothing would be $0.2. Or 0.2 mole in this case. So 0.3 mole, 0.2 mole as well. So just from the mass of one thing, we can convert it to mole. We can find the mole of the other things. Why must we convert to mole? Because the recipe tells us in mole unit. This recipe 1N2 plus 3H2 equals 2NH3 is in mole. So we have to convert whatever information we have into mole. So just like here, 1 piece of tomato plus 2 pieces of cheese becomes 1 piece of pizza. If I have like 2 slices of cheese, which might not be the same as 2 pieces of cheese, we might not be able to use this formula as a reference, right? Or for example, if I have like 1 kilogram of tomato, can I use this formula still? We cannot, right? Because the formula is 1 piece, 2 pieces, and 1 piece. So if we have like 1 kilogram, then 1 kilogram must be converted to piece. So for example, like 1 kilogram is 5 pieces of tomato. So then 5 pieces, 10 pieces, then 5 pieces, we can use it. So just like here, if you have like mass, so gram, we cannot directly use it as comparison. We have to change it into mole first. Okay? So now let's move this reaction down here. Plus 3H2 becoming 2NH3. So now let's say that we have this 0.1 mole, 0.3 mole, and we have like 0.2 mole. Yeah. So this we have the mass is 2.8 gram. So if you're asked the mass of the other things, now we can find it. Because mole is mass over MR, so mass would be mole multiplied by the MR. So if you would like to find, for example, the mass of NH3, it would be the mole of NH3 multiplied MR of NH3. So the mass would be 0.2 mole multiplied, well, nitrogen is actually 14. Hydrogen is 1. So 14 plus 3 times 1, which is the molecular mass of NH3. So the mass would be 0.2 multiplied 17, or in this case 3.4 gram. Something like this. So with the information of one thing in a chemical reaction, we can find the other things. But sometimes mole is not all that is, because we have different units and different conversions that can lead to mole. So not only that. Here we have hydrogen, which is a gas. And it's actually kind of rare for us to discuss a mass of a gas, right? It's more common for us to discuss a volume of a gas. So this is where I introduce a new triangle. the second triangle is actually a volume of gas. So volume of gas is equals to the mole, yeah, multiplied by 24 decimeter cube. This condition can be used in room temperature pressure, or RTP. So if it mentions RTP or room temperature pressure, then this relationship is true. So for volume of gas is equal to the mole multiplied 24 decimeter cube. Meaning that if you have the volume, you can find the mole. And if you have the mole, you can find the volume. So mole is actually equals to the volume of gas divided by 24 decimeter cube. So for example here, in this reaction still, you are asked to find the volume of hydrogen gas. Then we can easily find it. The volume of hydrogen gas is equal to mole of hydrogen multiplied 24 decimeter cube. So it's 0.3 multiplied 24 or 7.2 decimeter cube. So this is the volume of hydrogen. So now we've seen two triangles, the mole triangle and also the volume of gas triangle. Is there anything else? Yes, there is a third one. It's called the concentration of liquid triangle, of solution. Yeah, liquid or solution mostly. So this is, we use for solution. We have what is called concentration. So concentration is a unit of how packed a solution with a certain particles. So the unit is actually, the formula is mole per volume. So mole over decimeter cube. Yeah, just imagine that you have a bigger glass. So both contain 500 centimeter cube or like 0.5 decimeter cube. Yeah, it's like 500 milliliter. So now let's say that you put here 11.7 gram sodium chloride. And then here you put 23.4 gram sodium chloride. Now I ask you, which one would be saltier? I believe that you would answer the right bigger glass would be saltier, because for the same number of volume, you have the exact same, the bigger mass that you put in the same number of volume, right? But what if I change the situation? So now this part, so this thing, this thing, I reduce the volume, so it's not like 500 anymore. So let's say now it becomes 300 centimeter cube or 0.3 decimeter cube. So now which one is saltier? So now you might not be, it's not as straightforward. Because the right one, they have more mass but more volume. So less concentrated, right? But the left one, they have less mass but less volume as well. So the saltiness you have to kind of taste. Or another way, we can also check the concentration. So concentration is mole divided by volume. So now let's count the mole for this part. So the mole is actually mass over mR. NaCl, so Na is actually 1123 and Cl is 1735.5. So combined, the molecular mass will be 58.5. NaCl combination of those. So here, for the first bigger glass, 11.7 gram divided by 58.5, or it will be 0.2 mole. For the second bigger glass, so M over MR, 23.4 gram divided by 58.5, or it will be around 0.4 mole. Now, if we want to plug in the formula of concentration, mole over volume, so 0.2 mole divided by 0.3 decimeter cube in this case, so 0.67 mole per decimeter cube on the left bigger glass. While on the right bigger glass, the concentration would be mole over volume, 0.4 mole divided by 0.5 decimeter cube, meaning that we have 0.8 mole over decimeter cube. So all in all, the right bigger glass has a higher concentration still. So it's still saltier. So this is how you use this triangle, the concentration triangle. Finally, we have what is called by the number of particles triangle. So number of particles. Number of particles. So this guy here, named Avogadro. So there is this guy, named Avogadro. He somehow calculated the number of particles in substances, in molecules. And he found out that for every mole of anything, any atoms, any compounds, any molecules, that the number of atoms would be equal to the Avogadro constant, which is 6.02 10 to the power of 23 particles. So this is a constant. So for example, you have 0.2 mole of carbon dioxide. What would be the number of particles? It will be just mole multiplied by the Avogadro constant. So 0.2 mole multiplied 6.02 10 23 particles. So particles per mole, particles per mole. So the result would be either 1.204 10 to the power of 23 particles. So it would be this amount of particle inside 0.2 mole of carbon dioxide. Let's discuss one number, one example that incorporates maybe all of these triangles. I can make you an example. So magnesium plus hydrochloric acid forming MgCl2 and hydrogen gas. The first thing that you need to do for mole concept calculation is to balance. So balancing starts from the metal first. So the metal is already balanced. And then the non-metals, Cl on the right side we have 2, and the left side we have only 1. So multiply by 2. And then finally the hydrogens and the oxygens. Okay, hydrogen and oxygen come last for balancing. So now this reaction is balanced. So let's say that you have here 2.4 gram of magnesium. Then the question would be, what is the mass of this magnesium chloride? What is the volume of this hydrogen gas? And what is the concentration if of hydrochloric acid, if the volume of HCl is 0.2 decimeter cube or 200 milliliter. All of this can be answered if you find the mole of everything. So now with the only information that we have in the question, 2.4 gram of magnesium, we can find the mole. So the mole of magnesium would be the mass of magnesium divided by the atomic mass of magnesium. Why atomic mass? Because it's only one thing, magnesium here. So magnesium actually is 1224. So the mass is 24. So mole of magnesium is equal to 2.4 gram divided by 24, which is 0.1 mole. So this is the mole of magnesium. With this in mind, we can find all the other answer. So you see here that there is no number in front of magnesium. If there is no number, it means it's just 1. 1, 1, so 1, so 1. So imagine that one magnesium or one piece of clothing, the price is $0.1, 0.1 mole. What would be the price of two things? 2 times, so 0.2 mole. What would be the price of also one thing, 0.1 mole as well? What would be the price of the other thing, 0.1 mole as well? So if you find one thing, so here, you find, here you can also use it here, also the same. With one information you can find the other. So now, what is the concentration of HCl? Concentration is mole over volume. So 0.2 mole, the thing that we have here, divided by 0.2 decimeter cube, or 1 mole over decimeter cube. So what is the mass of magnesium chloride? The mass is equal to the mole of magnesium chloride multiplied the MR of magnesium chloride. So it's equal to 0.1 mole multiplied by the molecular mass of magnesium chloride. So magnesium is 24, Cl is 35.5. So magnesium chloride would be 24 plus 2 times 35.5, yeah, which means 71. So in total will be 95, yeah, 95. So 9.5 gram. Finally, what is the volume of hydrogen? The volume of gas, yeah, is the mole multiplied 24 decimeter cube. So it's 0.1 mole multiplied 24 decimeter cube, or 2.4 decimeter cube. If you need to find also the number of particles of any of these atoms or molecules, you can easily find it using the number of particles equals to the mole multiplied by the Avogadro constant. Yeah, for example, you want to find the number of particles of hydrogen, so just the mole of hydrogen multiplied by Avogadro constant. So 0.1 mole multiplied 6.02 1023, so will be 0.602 1023 can, or you want to make it a standard form like this also can. So these answers are acceptable for me. So these are all about the mole concept, still about the mole concept. I would like to give one example of a rather tricky thing to compare. For example, you have a reaction 2A plus 3B becomes, let's say, 5C. Yeah. Let's say that here for B, finally you find the mole. Yeah, the mole is actually 0.6 mole. What is the mole of C and what is the mole of A? It's tricky, right? Because it's not as straightforward like the previous reactions. Oh, yeah, it's just 2 times or just 3 times. No, but this one is tricky. So what do we need to do? If I were you, I would actually visualize like this. Like 3 pieces of clothing, the price is $0.6. So what would be the price of 2 pieces of clothing and 5 pieces of clothing? I would find the price of 1 piece of clothing first, right? So 1 piece of clothing would be $0.2. 0.6 divided by 3, right? Meaning that 2 pieces of clothing would be 0.4 mole. And this thing would be 0.2 multiplied by 5, so 1 mole. Okay? So remember that if you want it, if the numbers in front of the reaction is tricky, you can visualize it as such. So I hope this video helps and good luck.